Hey, how are we? It's Mr. Estrada here, and in this video I want to show you how to make a piecewise function continuous when you are given these constants a and b or some other letter. So let me just show you an example of what this could look like potentially right now. So I went ahead and I graphed a plus bx, and I graphed 2 comma 3, and I graphed b minus ax squared, right? So that all comes from this information that I'm given right here. But I don't know what a and b is, right? A and b could be anything right now. So what the problem is telling me to do is to consider this function that I'm given right now, which is a piecewise, and to determine the values of constants a and b so that the limit exists and is equal to f of 2. So in other words, what it actually wants me to do is to make this continuous, right? Make this continuous at this point 2 comma 3. So that's what I want to show you in this video. How do we make this thing that's broken up continuous so that it's just one function that is continuous so that you don't have to pick up your pen to draw it? Okay, so let's recall the definition of continuity. So remember, if a function is going to be continuous, the limit from the left must be equal to the limit from the right. So in this case, the left-hand limit is going to come from this bottom part right here, right? Because that's the less than. So the left-hand limit comes from b minus ax squared. And then the right-hand limit is going to come from the top one because that's the greater than. And that says a plus bx. So in order for the function to be continuous, the heights from the left and the right must be the same. And then you must have a value f of, in this case, it's going to be f of 2 that exists. So in this case, f of 2 is equal to 3, right? That's what I'm given. Excuse me, let me move that over. That's what I'm given right over here. So what can I do with this, all this information that I'm given? What you want to try to do is you want to try to make a system of equations. So I know that a plus bx must be equal to 3. And how do I know that? Well, because I know that f of 2 is equal to 3. Right? They gave me that part right there. And I know that b minus ax squared must also be equal to 3 because I want the heights from the left and the right to be the same, right? I want both those heights to be the same. So I get this little system of equations from this information. So a plus bx must be equal to 3. b minus ax squared must be equal to 3. Now, I also know that at that point, x is going to be equal to 2. So I actually went ahead and I substituted 2 in for these x's. So that's how I got a plus 2b equals 3 here. And then if you substitute 2 in here, you're going to get minus 4a. And then I just switched it around because it's going to make elimination easier for me. So I got this system of equations that I want to go ahead and solve for you right now. All right, let me just move this up a little bit. So to solve this system of equations, what I could do is I could go ahead and multiply this by 4. And I'm going to get 4a plus 8b is equal to 12, right? Just go ahead and distribute that 4. And then below that, I get negative 4a plus b equals 3. I didn't do anything to the one below. So then these cancel out. 8b plus 1b is 9b. 9b equals 15. Divide both sides by 9. And I get b is equal to, so 15 over 9 reduces to 5/3. So b, I'm going to go ahead and write that here. So b is equal to 5/3. So if I were to go back to that graph, remember I showed you this graph in the beginning? I could write 5/3 for b. So let me go ahead and do that now, just to give you a little visual, right? You're not going to be able to use this graphing a test, but it's a nice visual so that you can sort of tie together these concepts. So you could still see, right, they're not joined together yet, so I'm going to need that value of a. So it's going to be a plus b is 5/3 times 2, because that's the value of x there, at x equals 2. So then I get a is equal to, that's going to be 3 minus 10/3, and then that's going to be equal to negative 1/3. Okay, so just go ahead and you're going to have to work with fractions there, right? Because that's going to be 5/3 times 2. You get 10/3 minus 10/3 on both sides. That's how I got that. All right, so I did skip some steps there, but I'm sure you can figure those out on your own. So let's go back to that graph and let's make a negative 1/3, and let's see what happens. So a negative 1/3, and you could see, right, I get one graph that's continuous now, right? That means I can now draw this without picking up my pen. That was the objective here. So to solve these types of problems, remember that the limit from the left must be equal to the limit from the right. So we have these two limits, they must be equal to each other. In this case, they both must equal 3 because that's the height of the function that we want when x equals 2, right? So, sorry, I meant to write 3 there. So we want both of them to be equal to 3, right? And so we get this system of equations here. And then what I did is, in that system of equations, I substituted 2 for x, because that's the split point. That's what I like to call it. That's where we're trying to join the two functions. So substitute 2 for x, and then just take it from there, right? It's a system of equations that you have to solve. I hope this video helps. Take care.